Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 3.6 on the transformations of linear functions, in which we ask the essential question, how does the graph of the linear function f of x equal x compare to the graphs g of x, which is f of x plus c, and h of x, which is f of the product c times x. So here's what we're going to be doing. We're going to take a function, and we're going to be modifying its output by adding to it, and we'll actually be multiplying it as well. Or the other option is to do something to the input, like multiply. We have lots of different combinations, so let's get started right now. This page here, you don't need to write any of this down. I just want to give you a little preview of what's happening in the lesson. We've got three different types of transformations. We have one called translations. We've got one called reflections. And we've got one called stretch and shrink. And we're going to do this, and I showed you this on the previous screen a little bit, by modifying by multiplication or addition or subtraction, either the input or output of the functions. You got to kind of keep straight which ones you're doing here. There's a lot of information in this lesson. The first type of transformation we're going to talk about is the translation. And a translation is a transformation that shifts the graph horizontally or vertically. Okay, so to translate horizontally, we're going to subtract the number of units to shift from the input. Okay, we're dealing with the input here. So let's talk about y equals f of x. This black line represents y equals f of x. This is what we're going to call the parent function. And from this parent function, we're going to modify this to produce the red and then the blue lines. In order, let's talk about the positive case here first. In order to shift the parent function to the right in a positive direction, we're going to subtract a positive number from the input. That's what this says. We're subtracting from the input. And this is a positive number, right? And to shift it to the left horizontally, we'll subtract from the input, but we're subtracting a negative number. But when we subtract a negative number, remember, it looks like we're adding. So we're subtracting a negative number from the input. What about a vertical shift? To shift vertically, we're going to add the number of units to shift to the output. Okay, so here's our parent function. If we add a positive number to it, k is greater than 0, then we're going to shift it up vertically. If we add to it a number less than 0, a negative number, we're going to shift it down. So this will look like subtraction sometimes because we're adding a negative number. And this is to the output. That's because it happens after the f of x. Okay, so let's take a look at an example here. It says let f of x equal 2x minus 1. We want to graph g of x, which is f of x plus 3. So we're adding to the output in this one. So that should be a vertical shift. This should be a vertical translation up. And in this one, we're adding to the input, which is really subtracting a negative number. So subtracting a negative number, adding to the input means this thing's actually going to shift to the left. I mean, it seems like plus 3 should go to the right, but it's the opposite when we're dealing with this. It's going to shift. It's going to horizontally translate to the left 3 spaces. Okay, so let's take a look at why that happens. I'm going to set up a little t-table here. X and then f of x. I'm going to just use -1, 0, and 1. Okay, so if x is -1, then f of x will be -2 times -2 plus -1, -3. If x is 0, then f of x will be -1. And if x is 1, 1 times 2 is 2, 2 minus 1 is 1. Okay, so I'm going to plot those 3 points here, -1, -3, 0, -1, and then 1, 1. Those are my 3 points. And I'm going to draw my line through it. There's my parent function. This is my parent. This is f of x. Okay, so let's take a look at g of x, because we're just adding to the output. So this should be pretty easy to do here. G of x is just f of x plus 3. Okay, so -3 plus 3 is 0. -1 plus 3 is 2. And 1 plus 3 is 4. So now I have new y values. So -1, 0 is here. 0, 2 is here. And then 1, 4 is here. And this will look like this. This is g of x. And we said this was we're adding to the output. So this is actually a vertical translation 3 spaces up. So this point is now 1, 2, 3 spaces above it. This is 3 above. Let me kind of arrow that in here. That's a very poor arrow. 3 up. This one is 3 up, and so on. Every point on this line is now 3 spaces higher. That's what translates this up. Now let's take a look at the this second one here, t of x. I need to do a separate. Okay, so -1, 0, and 1. Because what's happening here is what? X plus 3, we have a new input. So 3 plus -1 is 2, 3 plus 0 is 3, and 3 plus 1 is 4. And now I'm going to apply this to f of x. This will be my t of x. So t of x equals f plus 3. Okay, so here's my new input. So 2 times 2 is 4. 4 minus 1 is 3. 3 times 2 is 6. 6 minus 1 is 5. 4, my new input 4. 4 times 2 is 8. 8 minus 1 is 7. Okay, so -1, 3, 0, 5, and 1, 7. Okay, and this will be t of x. This is a horizontal translation to the left. And let's see, this one's off a little bit. Let's straighten him out. These 3 spaces, this one is actually shifted this way. Now, I know it's kind of hard to tell the difference between a horizontal and vertical translation just by looking at it. Mathematically, it's going to work out the same, but just know that modifying, adding to the input is going to be a horizontal, or adding or subtracting, I should say, is going to be a horizontal translation. Adding to the output is going to be, or subtracting, either way, it's going to be a vertical translation up and down. Okay, there's our first one. Reflection. Reflection flips the graph over the line of reflection. Think mirror image. So we're going to be reflecting over the axes, over the x or y axis. So to reflect over the x-axis, we're going to multiply the output by -1. So here's our parent function, f of x. Multiplying by -1, we get negative, or the opposite of f of x. So what's the effect here? Well, let's say this point here, let's say this point is y equals, I don't know, 1, 2, let's say it's y equals 3. Well, for the same x value now, we'll have y equals -3. So it reverses the value, no, it reverses the sign of the y values. And let's say this was y equals 3. Well, if I multiply that, I'm here at y equals +3. The reflection over the y-axis means we're going to multiply the input by -1. So what was, let's say, x equals, let's call this 5. X equals 5. Here's x equals 5. Well, now it's going to be over here. X equals -5. So it reverses the, that's a +5, by the way. It reverses the sign of the input. Okay, let's take a look at an example here. Let f of x equals 1/2 x plus 1. Okay, so let me do that. Okay, so there's that. There's our parent function, f of x. Now it says graph g of x, where we multiply, we want the opposite of g of x. Well, that's going to be pretty easy for us to do, because I already have f of x. G of x is the opposite of f of x. So this would be -1/2. This would be -1. This is -1.5. So graphing these, -1. Now it's going to go drop down here to -1/2. 0, instead of being 1, will be -1. And 1, instead of being +1/2, will be -1.5. So that's this one. And let's take a look at the t of x, which is f of -x. Okay, so again, I'm going to create a -1, 0, 1. So opposite of x will be 1, 0, -1. So this should be pretty easy, because I know I know 1 is going to be the same as this one, 1.5. 0 is going to be the same. 0 is going to be 1. And then -1 will be this one. It's the same, 1/2. And this is going to be f of -x. Okay, so 1, 1.5. So 1, let me do this in red. 1, 1.5 would be here. 0, 1 is here. And then -1, 1/2 is here. Sorry, I'm going to graph -1. I'm going to graph sorry, but I had that backwards, so it's -1 going to 1.5. Oops, let me make that a little clearer. -1 going to 1.5. Sorry about that. 0 still goes to 1. So -1, 1.5, and then 1, 1/2 down here. So this one is gone, and that one's gone. Okay, so there's my there's my reflection of the parent function. This one is across the y-axis. This one's kind of this way, right? This one's across the y-axis. This one's across the x-axis. Okay, I'm going to stop here for now. I'm going to call this part one. I'm going to pick up on part two on the next. I'm going to continue this video. I don't want this video to get too long. All right. So thanks a lot, and I'll see you in part two.